Enthalpy of neutralization. Enthalpy of neutralization is defined as the enthalpy change when 1 gram equivalent of an acid or alkali is completely neutralized by alkali or acid at a particular temperature. So for an example, if you are treating a strong solution of sodium hydroxide with another strong solution of hydrochloric acid in its dilute form. So what happens here is sodium hydroxide is a strong base and hydrochloric acid is a strong acid. And here, as when we see the reaction here, sodium hydroxide is completely ionized form because it's a strong base in its aqueous solution, that means in dilute solution. So Na positive and OH negative. And here hydrochloric acid in a solution form is fully ionized. It is a strong acid. So here H positive and Cl negative. So what happens? Na positive combine with Cl negative and form sodium chloride. So for an example, sodium hydroxide plus HCl gives sodium chloride plus water. So in the case of strong electrolyte, there is a complete degree of ionization. So here sodium hydroxide is a strong electrolyte, Na positive, OH negative, and hydrochloric acid is H positive, Cl negative in ionized form. So literally sodium positive combined with the Cl negative ion and then form sodium chloride and plus water. So literally the enthalpy of neutralization means, in other words, the formation of undissociated water. That means OH negative plus H positive gives H2O. So enthalpy change in that case is also minus 57 kilojoule. So enthalpy of neutralization in the case of strong acid and strong base in its dilute solution is always minus 57 kilojoule. Weak acid and strong base, for example acetic acid with the sodium hydroxide, in that case the enthalpy of neutralization is less than expected 57 kilojoule. The reason for the decrease in the value of enthalpy of neutralization of weak acid and strong base is some of the energy is utilized for the ionization of acetic acid. So shortly, in order to remember that, in the case of strong acid and strong base, the enthalpy of neutralization value is always a constant, that is minus 57 kilojoule. But in the case of weak acid or weak base or weak base and strong acid, in that case the enthalpy of neutralization values little bit lesser than the expected the constant value. So in that case, in the case of weak electrolytes, some of the energy is utilized for the ionization of a weak electrolyte.